Welcome back, guys. So this is question 2.11 of section 2.3, and the statement of this question is for the circuit shown in figure P2.11. So this is P2.11, and this is the figure where we have this independent current source, this resistor, and this is the polarity of the voltage here. Okay, so what do we have to do? In part A of it, we have to find V. Okay, so let us first find V from it. So this is part A, and to find out V, we know the Ohm's law. So according to it, V is equal to I into R. Okay, so here in order to find the V, we need to find out the value of I and R. So the value of R, which is the only resistor here, so all the voltage will be consumed across it. So the value of R is known, the value of I is given by this current source. So therefore let me write it. So 15 multiplied by 10 raised to power minus 3 for 15 milliamps multiplied by R, so that is 3 multiplied by 10 raised to power 3 because of this kilo. Okay, so these two will cancel out and ultimately we will get 45 volts. Okay, so this is the value of V in part A. Okay, so after it we have to find the power absorbed by the resistors. This is part B. In order to find the power absorbed by the resistor, we have to use the formula, which is P is equal to I square into R. Okay, or there is another formula as well, and that is V square divided by R. Similarly, for the sources, as we have done in our previous questions, for the sources, the value of the P or the power is always I multiplied by V, which is the current through that source and the voltage provided by that source. Okay, so this is for the sources, while these are for the resistors. Okay, for the impedances, we will discuss them in our upcoming videos. Till now, let us concentrate over the resistors, as we have a resistor here. Okay, so you can take any of these formulas and it will give you the similar output. So let me take this formula, V square divided by R. So P of R is V square divided by R. So the voltage across it is known, and that is 45, as we have already found it out. 45 square divided by R, and R is 3 kilo ohm or 3000. Okay, so let me find it out. 45 square, this is 2025 divided by 3000, so that is 0.675. okay, so that is the answer, or we can also write it in terms of the milliwatt. So it would be 675 milliwatt. Okay, that is the solution of part B. In part C, it is given that reverse the direction of the current source and repeat part A and part B. So here this is the current source and we have to reverse it. Let me reverse it here. Okay, so let me redraw it. So this is the source, this is the resistor. Okay, and the polarity should remain the same. This is V, this is 3 kilo ohm, while it is given that we have to change the direction of this current. So this is 15 milliamps. Okay, so therefore the value of current is now what? That is minus 15 milliamps because of this value. Okay, so by changing these values, all the previous values will be negative, as we will write here the value of I equal to minus, so it will become here V equal to minus 45 volts. Okay, what does it mean? It means that the polarity we have selected is this one, but the actual polarity which is given by this negative sign is opposite as that we have supposed here. Okay, so this is positive, but the actual polarity here is what? The actual polarity is plus minus, and that has been due to this opposite direction of the current source. Okay, so that is for this part of question. In part B, which we have to do again, let me use the similar, as the values of the voltages are now here. So negative minus 45 square will be the similar one, and this is, and the value of power will remain the same because of the value here, and the value of power will remain 675 milliwatt. Okay, the value of the power will remain the same. So that's it for today, in which we have seen a very basic circuit and analyze it by using the Ohm's law and the formula for the power, for the resistors, okay, and for the sources as well. Okay, so if you have any question, you can ask me in the comment box. See you soon.